good afternoon or evening or morning or whatever it is whenever you're watching this. Mr. Fish here. Hope you are being kind to Mr. Bussey today. Sorry I can't be with you, and I really appreciate him being there to fill in today. We're going to do this lesson 3-4, construct functions to model linear relationships, page 189 in your books. You should have your book open, filling it out just like you do when we do notes in class. So if you're not ready yet, go ahead and pause and get your book ready, and then let's do this. I'll be back tomorrow. That's the plan, and then we'll review this and we'll go over it. I know it's not as easy to get a lesson down when I'm not there to ask questions and things, but this should all feel very familiar. This is all writing slope-intercept equations. And so all we have to do is find the slope and the y-intercept and write the equation as we've been doing for weeks now anyway. So this should be okay. Warm-up question. Eric wants to buy a new mountain bike that costs $250. He has already saved $120 and plans to earn $20 each, or to save $20 each week from the money he will earn mowing lawns. He thinks he will have enough saved after 7 weeks. So complete the table and graph the data. So when he opens the account, or when he comes up with this idea at 0 weeks, he already has $120 in his account. That number should tell you something right there. After 1 week, he's adding $20 each week to that. So after 1 week, he would have $140. And then after 2 weeks, he's going to add $20 more, so that's going to be $160. And then he adds $20 more, so that's going to be $180. And we could keep making that table. We could go out. 4 is 200, and 5 is 220, 6 is 240, and 7 is 260. So he thinks that after 7 weeks he will have enough money. Hey, look, he does. After 7 weeks, he's got $260, so that's good. We also can see it on the graph. Here at 7 weeks, he's up here above 240. This is going up by 30 at a time, which is kind of weird, but that's okay. And we see it's right there at 260, just like it should be. How can you tell that the relationship is a linear function from the table? Well, on the table, we can tell it's linear because of what it's doing here. It goes up plus 20 every time. And because it does the exact same thing every time, we call that a constant rate of change. And since it's a constant rate of change and so on, we know that it's going to be linear. How can you tell it from the graph? I love these questions. How can you tell this? How can you look at the graph and tell that this is linear? Because it makes a straight line. Doesn't get much easier than that. So since that makes a straight line right there, it is linear. There you go. It's got a constant rate of change. All right, that is basically what I wanted to get out of the warm-up. So next, oh look, just as you thought there'd be a video. Let me see if I can get that on here. That button. Oops. I got to back up here. Should have had this set up. Sorry. Scrolling. There it is. And resize the screen a bit. Get it into view. Here we go.
How can you use a function to represent a linear relationship? Think about this question during the lesson. A plan for a skateboard ramp shows that the plywood for the triangular sides of the ramp should be cut such that every 9-inch increase in height is accompanied by a 33-inch increase to the base. What is the height of the skateboard ramp? The first step is to use the graph of a line to represent the situation and to determine the slope of the line. Show the height on the y-axis and the length of the base on the x-axis. We know that when the height increases by 9 inches, the base length increases by 33 inches. So the point with coordinates 33, 9 represents one possible base length and height of the ramp. A second increase of 9 inches in height and 33 inches in base length represents another possible height and base. The line shows that for every 9-inch increase of height, the base length increases by 33 inches.
That's should feel familiar. We've been doing this for weeks now. This is just rise over run, and they're using that to find the slope of the line.
So the slope of the line is the change in height, which is 9 inches, divided by the change in base length, or 33 inches. The slope is 9 divided by 33, which simplifies to 3/11. Now, let's use the slope to write an equation for the function shown in the graph. The equation is y equals 3/11 times x. Y represents the height. X represents the base length. And 3/11 is the slope. Now, use the equation to find the height for a base length of 110 inches. Which variable should be set equal to 110?
Select your answer.
We have an equation, and we want to take this number, 110, and put it into the equation for one of our variables. Would we put it in for y, which measures the height, or would we put it in for x, which measures the base length? Well, since it says the base length is 110 inches, and the x-axis measures the base length, that seems to tell us where it should go. It should go in for the x.
Substitute 110 for the variable that represents the base length, which is x. Then simplify to find that y equals 30. Our results show that the height of the skateboard ramp is 30 inches when its base length is 110 inches.
Now you know how to write the equation and use it. We've been doing that for weeks now. Let's look at some examples. This goes back to the one that we just did, the follow-up to the video. A skateboard ramp with a base of 110 inches has a height of 30 inches. A plan for a new ramp requires that for every 3 inches of height, there are 15 inches of base length. So they're changing the slope on us. 3 inches of height over 15 inches of base length. That is literally rise over run. 3 inches of height over 15 inches of base length. So rise over run. And we would simplify that to 1/5. And then all we would have to do is write the equation. So y equals 1/5 x. Should feel familiar. We've done this lots and lots of times already. Okay, let's keep going. The cost to manufacture 5 toys is $17.50. The cost to manufacture 10 toys is $30. Construct a linear function in the form of y equals mx plus b that represents the relationship between the number of toys produced and the cost of producing them. So determine the constant rate of change. In order to find the rate of change, that's also called the slope. And to find the slope, we need to do our little slope formula. y2 minus y1 over x2 minus x1. We've got some ordered pairs here. We've got 5 toys costing $17.50. That's something we can graph. That's an ordered pair. And we need to think about which one of those is x and which is y. But we have a rule. Rule number 1, money goes on top, so money is the y. So we can do 17, actually, let me pause there for a second. We have our other ordered pair, which is 10, 30. Money goes on top, and I want to do 30 as my Y2 value. 30 minus 17.5 over 10 minus 5. So 30 minus 17 would be 13. That's going to be 1250 over 5. 12 and a half divided by 5 would be 2.5, 2.5. So our M value is 2.5. Now this is where it gets a little bit tricky. We haven't done this before, but we know what we need to do. In order to write our slope-intercept equation, we need two numbers. I need to know the M and I need to know the B. Well, I just found the M. I know what that is, but I don't know what the B is. And what we did yesterday and in the previous lesson was we would have a table that had the X, Y values. And if you'll remember, we needed to have a specific number in for X on our table so that we could find the Y-intercept, right? We needed a 0 on that table. And so we would do what we needed to do to get a 0 there. If we had to count backwards or if we had to use the slope or whatever it was, we would find a way to get a 0 on our table to find the Y-intercept. But we don't have a table. What we do have is an equation, and we've got a couple of ordered pairs. So I know that I can always use an equation, y equals mx plus b. I know what m is because I just solved for it, and I have two ordered pairs that can give me a y and an x. The only number I don't know is my b value. That's the one I'm trying to find. And so I'm going to use one of my two ordered pairs. I usually choose the one with the lowest numbers because low numbers are easy to work with. So I'm going to use 5 and 1750. 5 is my x value, 1750 is my y value, and I have an m value. So 1750, that's the y value, and that equals m is 2.5 times x, and my x value is 5, plus b. And now I'm solving this equation for b. So 1750, 2.5 times 5 is 1250, plus b. Now I just need to subtract 1250. And 1750 minus 1250 is 5. So my y-intercept is 5. That means for every toy that I produce, I have $5 of expense before I ever even have produced a toy. There's $5 of, I got to pay the electric bill, I've got to buy the robots that make the toys, I got to buy the paints and supplies and all that stuff before I ever even make a toy. So that's at 0 toys produced. I'm already out $5, right? So my equation now is just going to be y equals m is 2.5, so 2.5x, and my initial value or y-intercept is 5. So y equals 2.5x plus 5. We're going to do this a lot. We're going to get a lot of practice over this, doing this using our slope-intercept equations to solve for various numbers. Should be something we can do, but we'll keep practicing at it if you're struggling. Very similar problem, even though the details are different, same structure, we're going to do just about the exact same steps. Jen is tracking how much food he feeds his dog each week. After 2 weeks, he's used 8.5 cups of food. That sounds like an ordered pair. After 5 weeks, he has used 21.25 cups. That sounds like another ordered pair. So I have two ordered pairs. I can find my slope. Once I have found my slope, I can then plug some numbers into the slope-intercept formula and solve that to find my y-intercept. Okay, so first things first, let's find the slope. 21, and I'm just going to use decimals. Decimals are going to be my friend on this one. 21.25 minus 8.5 over 5 minus 2. And 21.25, I'm getting my calculator out here. 21.25 minus 8.5 equals 12.75. And 5 minus 2 is 3. 12.75 divided by 3 is 4.25. So 4.25 or 4 1/4 cups of dog food every week is what he's doing. Okay. 4 1/4 cups of dog food a week. Now I can use my my first ordered pair and my slope to see what my y-intercept is. All right. I'm going to change colors for that just because I can. It's easy to do. All right, so to find my y-intercept, I would do y, which is 8.5, 8.5 equals my slope, 4.25, times 2 plus b. So 8.5 equals 4 1/4 times 2 is, well, that's 8.5 plus b. And so if I subtract 8.5 here, 0 equals b. That tells me that my y-intercept is the origin. So this is a proportional relationship. All right. That's good to know. So now I don't have a y-intercept, or my y-intercept is 0, so I don't need a plus 0 on the end of my equation. All I have to do to write the equation is y equals 4.25x, or 4 1/4 x. Okay, that wasn't too bad. Found our slope, discovered that our equation was proportional, and just wrote out our proportional equation there. All right. Here's another example. The graph at the right shows the relationship of the number of pages printed over time from a printer. With a set warm-up time before each printing, what function in the form of y equals mx plus b models the relationship? I take a note, guys. Look what they did to us here on this one. Where did they put time? They put time on the y-axis. This is so weird that they did that. It's not illegal to do it. It's just weird. So instead of talking about pages per minute, which is what we would normally do, now we're going to talk about minutes per page. That's going to be our slope, which is kind of weird, but it still works. It can still be an equation that we can make sense of. So we're going to do our slope. First of all, now that we have a graph, I could look at two ordered pairs and do y2 minus y1 over x2 minus x1, but I also have a graph here that I can just count. And I can go from here, I can go up 1, 2, and then right. I have to count by the way the graph is numbered. So I'm not going to count 1, 2, 3, 4. That would be wrong. I'm going to go up 2 and then right 5, 10, 15, 20. And so my run is 20. My rise is 2. So 2 over 20 reduces to 1/10. So my slope is 1/10. And then I can see my y-intercept. It's right there. I don't have to solve for it like I did on the last examples. When you have a graph, you can just count the slope and you can see the y-intercept. And so it's right there for us to write the equation. All we have to do is write it. Y equals 1/10 x And then my y-intercept right there is 1. So plus 1. That's it. That one was pretty simple. All we had to do was count. All right, and that, I think, takes us down to the end of the, kind of the end of the lesson. Guys, all we're doing is writing the slope-intercept equations that we've been writing in the past. I know you can see it in your book, but I'm just going to point out to you here when you get to the end of that chapter or the end of that lesson, this is the wrap-up. The wrap-up is a simple restatement of our slope-intercept equation, and we're just looking for our slope or constant rate of change, and then we're also looking for the y-intercept or initial value. If we have those two numbers, we can write an equation. So let's go on. Oops. Let me get to the other screen. Let's go on and do some of these homework problems. I don't know that I'll do all of them for you. It's getting late for me, but we'll at least get you started with some of these. And who knows, maybe I'll get on a roll and we'll just do them all. A line passes through 2 points, 419 and 924. We need to write the function in the form y equals mx plus b. I've got to do two things. I've got to use the two ordered pairs to find my slope, and then I have to use one of the ordered pairs with the slope to find the y-intercept. So I need to do a little bit of math here. I'm going to do y2 minus y1, 24 minus 19. And then 9 minus 4. 24 minus 19 is 5. 9 minus 4 is 5, so the slope is just 1. Now I can use one ordered pair, the y and the x values, and the slope to solve for b. So y is 19, x is 4. 19 equals 1 times 4 plus b. So 19 equals 4 plus b. Subtract 4. 19 minus 4 is 15, and that is the y-intercept. Now I just need to write the equation. So I'm not done yet because it says write the equation in slope-intercept form. So the equation, y'all, needs to look like this. Y equals 1x plus 15. Now, I don't need to put the 1 there because anytime you have a variable by itself, it means just one of those variables. So it really would be best just to write it as x plus 15. Here's another very similar example. This one, they give us the y-intercept, so we don't even have to solve for that. We just need to find our slope. What is the linear function in the form of y equals mx plus b for the line passing through 4.5, negative 4.25 with y-intercept of 2.5? So this time, I only have one ordered pair. I don't know if it's proportional or not, so I can't use just one ordered pair to find the slope. I need to use this equation. I have a y value right here. I have an x value right here, and I know the y-intercept, which goes right here. So I can use those three values in the equation and solve for m, solve for the slope. So let's do that. Negative 4.25, that's a funny looking 5, equals m, which I don't know, times 4.5 plus 2.5. Plus the y-intercept. Subtract 2.5. And that's going to be negative 6.75 equals 4.5 times m. Did I do that right? 4.25. 4.25 negative minus 2.5 equals 6.75. Yep. And then if we divide by 4.5, we get negative 1.5. Negative 1.5 equals m. So our slope is negative 1.5. And we can write the equation because we have the y-intercept and we know the slope. So it would be y equals negative 1.5 m plus 2.5. That's hard for me to know how you guys are doing because I can't hear if you're groaning or if you're confused. Sorry, I'm just going to keep going. We'll do a few more of these at least. Car moving at a constant speed passes a timing device at t equals 0. After 8 seconds, the car has traveled 840 feet. So what linear function in the form y equals mx plus b represents the distance in feet the car has traveled in any number of seconds after passing the timing device? So, what in the world? They're telling us that it is a proportional relationship because it passes through t equals 0 at 0 distance. So I only need one ordered pair. So it would be 840 divided by 8, which comes out to 15. And so the car is traveling, what that tells us is 15 feet per second. That's not 15. Sorry. I knew something was wrong. That doesn't sound right. It's 105. It's not 15. Sorry, let me rewrite all that. That's terrible handwriting. It is 840 divided by 8, and 840 divided by 8 is 105. And since it's proportional, all I need is the slope. The y-intercept is 0. It's not going to affect my equation. So y equals 105x. Although they want us to use the letters D and T. Okay? So time is going to be our x value. Distance is going to be our y value. So distance equals 105 times time. All right, that's the proper way to write it. They did tell us to use D and T instead of y and x. Number 10, at time t equals 0, water begins to drip out of a pipe into an empty bucket. After 56 minutes, 8 inches of water are in the bucket. What linear function in the form of y equals mx plus b represents the amount of water water in inches W, in the bucket after t minutes? Minutes is going to be our x-axis once again. 8 is going to be our y-axis, our y value. So we would put 8 over 56, which is 1 over 56 divided by 8 is going to be 7. So that tells us that it is going at a rate of 1 inch every 7 minutes. 1 inch every 7 minutes of water. And we can write the equation y equals 1/7 x. But they did it again. Water so it should be W equals 1/7 T. I always forget to check that. I like using X's and Y's instead of D's and T's and W's. Number 11, the graph of the line represents the cost of renting a kayak. Write a linear function in the form of y equals mx plus b to represent the relationship of the total cost C renting a kayak for T hours. So we want to find some ordered pairs that we can count easily. Looks like the arrow is going to go through right there, and the arrow goes through right there. So from here up to here, it's going to be 2, 4, 6, 8, 10, 12 over 1, 2, 3, 4. So 12 over 4 is going to be the slope, which is 3. Okay. Next, we need to find the y-intercept, and the y-intercept is a little bit tricky on this one. We might be able to tell that it's about 5.5. No, 4, 6, 7, about 7, maybe 7.5. But what we can do, just like we've done on past ones, we've got an ordered pair here that is really easy to see. It's 1, 10, and I can use that in the equation really, really easily. So 10 equals 3 times x, which is, 3 times 1, plus the y-intercept. 10 equals 3 plus b, subtract 3, so 7 is b. And that's about what we expected it to be based on what we're seeing on the graph. It's just hard to read since it's not right on the corner. But now I can write the equation y equals 3x plus 7. All right, an online clothing company sells custom sweatshirts. The company charges $6.50 for each sweatshirt and a flat fee of $3.99 for shipping. Write a linear function in the form of y equals mx plus b that represents the total cost y in dollars for single orders of sweatshirts x. So that would just simply be y equals, it's $6.50 for each sweatshirt. So that's that. When we think about things that happen, we usually talk about the slope is going to be things that happen over and over again, where the y-intercept is something that happens once. So the slope is going to be $6.50 times the number of sweatshirts sold plus the $3.99 flat shipping fee. Part B, describe how the linear function would change if the shipping charge applied to each sweatshirt. Well, instead of doing $6.50 times the number of sweatshirts first and then adding $3.99, we would need to add $3.99 to the cost of the sweatshirt. So it'd just be $6.50 plus $3.99, then multiply all of that times X. So we would just add these two numbers together first before multiplying and see what that looked like. That would not be very pretty, I predict. To have to, your costs would go up very, very quickly because you would have to, it would just get more expensive. You're going to add $4 to every sweatshirt. All right. Store sells packages of comic books with a poster. Model with math. All right, we've got a linear function in the form of y equals mx plus b that represents the cost y of packaging containing any number of comic books x. So the first thing we have to do is find our slope, then find the y-intercept. All right. So the cost for each package, the posters, you get one poster each time. So the poster is affecting both of those costs exactly the same. So we're just going to kind of not worry about the poster on this part. As far as our ordered pairs, we're going to talk about the number of comics and how that affects the cost. So we would do first find the slope, 19.75 minus 12.75 over 13 minus 6. And 19 minus 12 would be 7. 13 minus 6 is 7. So 7 over 7 is just 1. That means each comic book is $1. That's reasonable. And to write our equation then, we would write y equals 1x plus the cost of the poster. Well, if each comic is $1, and we've got 6 comics here, that would be $6. So if we do 12.75 minus 6, 12.75 minus 6 is 6.75. So our y-intercept is going to be 6.75 because that's the cost of each poster. All right. So there you go. Is that all we need to suppose another? Part B. Suppose another store sells a similar package modeled by a linear function with initial value of 7.99. Which store has a better deal? Well, 7.99 is more expensive than 6.75, so they're charging more for their poster up front, even though their cost of the comic books is going to be the same. They said we get a better deal when we pay the lower price up front. Okay. I think that does all of the first page of your work for you. That's some good review. That's good. I know the next page, some of these are going to be a little bit trickier problems anyway, but we need some stuff to review when I come back on Thursday. So don't turn this page in. We will review this back page on Thursday and do some other work as well as a review on this topic. I am going to go ahead and assign the IXL for this one today. So if you have class time left, work on that IXL or work on the paper one, whichever you want to do. We'll go over some stuff on Thursday. Thank you and have a great day. Be nice to Mr. Bussey.